Okay, so now we've just finished solving linear systems by graphing. We are eventually going to look at other methods of solving, but before we get into that, I want to spend some time going over how to set up different types of word problems in terms of their linear systems, because there's a lot of different types of problems out there. I just want to show you guys many types of problems that are out there, so we can be able to set them up and go forward once we have the tools to be able to solve them. So today we're really going to focus on the process of defining the variables and creating the equations. We're not actually going to go through the process of solving. I'll show you the answers graphically, but right now, since the only way we can solve these is graphically, we're going to avoid going through those full solutions because there is going to be a faster way coming up soon. So take a look at this first situation here. We have the Athletic Council. They sell 835 tickets to the championship field hockey game, and they bring in a total of $5,792. Okay, and we're told that students pay $4 and non-students pay $8. And we want to figure out how many students and non-students attended the game. Okay, so what you always want to do first is define your variables. So since we're looking for how many students and how many non-students came to the game, those are going to be our unknowns. Okay, we'll choose our variables to represent those. So I chose X and Y for my variables. Very commonly you might choose S and N for students and non-students, but that's up to you. So define your variables, create your let statements. We're going to let X represent the number of student tickets sold and Y represent the number of non-student tickets sold. And there's enough information in this problem to actually create two different equations. And we're just going to take through it by piece and see what we can come up with. So the first thing we're told is, again, that they sell 835 tickets in total. Well, the 835 tickets are made up of strictly students and non-students. So that should tell us that the number of student tickets plus the number of non-student tickets should add to 835. So that right there will give us our first equation. X plus Y equals 835. Student tickets plus non-student tickets equals 835 tickets. So that's some information there, okay, which is useful. But now let's see if we can figure out another equation that's going to use the dollar amounts given. So remember that we were told that they bring in $5,792 total dollars, and they get $4 for every student and $8 for every non-student. So that means, if you take a look at the equation here, $4 for every student plus $8 for every non-student ticket sold should give you $5,792 in total. Okay, so what we want to make sure of is that our units match up. So if you look here, the right side of the equation is in dollars, 5,792. So we get $4 times the number of student tickets and $8 times the number of non-student tickets to get that total. Okay, and again, to solve this, you can graph it. Okay, I'll show you in Desmos how we can find the solution doing graphing, but we are going to look at algebraic methods in the coming days. Okay. Okay, so just so you can see what the solution is, in Desmos here we have the two equations, x plus y equals 835 and 4x plus 8y equals 5792. So here are the two lines on the graph, and we can see here we can find a point of intersection right there. So that would tell us that we sold 222 student tickets and 613 non-student tickets. Okay, so with that in mind, let's try and take a look at a second one here. Okay, so now we have someone owning a chocolate store. They sell two different types of chocolate. Dark chocolate costs $2 per kilogram and milk chocolate costs $4 per kilogram. I want to mix the two chocolates together, and together the mixture is going to weigh 60 kilograms, and it wants it to sell for $3 per kilogram. So he wants to figure out how much of each chocolate he needs to make a fair mixture that he's not going to get cheated on. Okay, so I'll start by defining the variables with you guys. There's a lot going on here, and it can be a little bit weird to work with. So we are two different types of chocolate. So $2 chocolate, which is the dark chocolate, and $4 chocolate, which is the milk chocolate. So we're going to let X and Y represent the amounts of $2 chocolate and $4 chocolate, respectively. Okay, what I'd like you to try to do, try and create the equations on your own first. Take a minute and try. And when you're ready to go through them together, push play. Okay, so here's the first equation. So I decided to use one equation involving the amounts of mixture. So we were told there's 60 kilograms in total of mixture. 60 kilograms in total, and there's going to be a certain weight of the dark chocolate, which was X, and a certain weight of the milk chocolate, which was Y. So you add your two weights together, it should be 60 kilograms. That would give us our first equation. X plus Y equals 60. Okay, so that one's not too bad. The second one's a little bit trickier to set up because now we're going to incorporate the value of the chocolate that's inside the mixture. So to set this up, well, every kilogram of dark chocolate I put into the mixture has a value of $2. So the value of the mixture is going to be $2 for every kilogram of dark chocolate. And I'm going to add to that $4 for every kilogram of milk chocolate. Okay, so what's going to represent here, they put this together, this is going to be the total value of the chocolate inside the final mixture. Okay, so now what I need over here is a total value of the mixture when I'm selling it. So there's going to be 60 kilograms of mixture. Okay, and each one of those kilograms is going to be worth $3. Okay, so again, $2 for every kilogram of dark chocolate plus $4 for every kilogram of milk chocolate altogether should give me a total value of $3 a kilogram for the 60 kilograms of mixture. So I get 2x plus 4y equals 3 times 60, which when I simplify that right side becomes 2x plus 4y equals 180. Okay, so I have one equation involving the amounts of the chocolate in terms of their weight, and another equation that involves the value of the mixture once everything's put together. Okay, and again, I'll quickly show the answer in Desmos so you can see what the answer is. We're going to solve it using other methods in upcoming lessons. Okay, so here are the graphs of the two lines in Desmos. You can see the intersection is at 30-30. So in this particular case, it's going to be 30 kilograms of each mixture. Okay, so next one, Caroline invests $1,400 in 2 different mutual funds. So if you're not sure what a mutual fund is, it's basically an investment. So you invest money in a mutual fund and it pays out a certain interest, usually on a yearly basis. So this particular one earns 7% a year, so at the end of that first year she gets 7% of her money back in terms of interest. And the other one earns 8%, so at the end of the year she gets 8% of that in interest. So we're told in 1 year she earns $104 in interest. We want to figure out how much she invested in each fund. Okay, so we'll define our variables first. So we're going to I'm going to use x and y again. So x will be the amount invested at 7% in that fund, and y will be the amount invested at 8% in that mutual fund. So to do the equations, again, first thing I notice here, we invest $1,400 in total. So that's the amount I put in, that Caroline put in up front. So there'll be a certain amount, x at 7%, another amount, y at 8%. So whatever amount invested at 7% plus whatever amount invested at 8% was $1,400. Okay, so that can give us our first equation, x plus y equals 1,400. Okay, for the second equation, we're going to now take into account the interest. So in terms of total interest, she's earned $104 of total interest after 1 year. And how's that interest made up? Well, it includes 7% of what she invested in the first mutual fund. So 7% as a decimal, remember we divide by 100. So that's going to be 0.07. So the amount she invested at 7%, so we get 0.07x. And she also gets interest from the 8% mutual fund. So we're going to add that to the interest, which is going to be 0.08 times what she invested in that mutual fund, which was y. So we get an equation of 0.07x plus 0.08y equals 104. And that will give us our second equation that we can use. Okay, you can quickly take a look in Desmos here. The intersection point is at 800, 600, so she invests $800 at 7% and $600 at 8%. Okay, one last one, and this one's a little bit different. So we have a lot going on in this question, so I'll walk through this one together with you. So we have a family, they travel 880 kilometers from St. John's to Halifax. They do part of the trip by car, traveling 80 kilometers an hour, and the rest of it by ferry at 16 kilometers an hour. And we're told that they travel 27 hours in total, and we just want to figure out how many hours they spend in the car and how many by ferry. Okay, so there's a lot of information going on here. So what I suggest you do is organize everything into a chart. Because you've got distances, speeds, and times, and 2 different methods of travel, by car and by ferry. So I'm going to organize everything into a chart. So I have distance, speed, and time, and I'm going to put a section here for by car, and another section here for by ferry. Okay, and just because I have information about totals as well, I include another row for that. So once this is all set up, I'm going to define my variables and start filling in some information. So for starters here, in terms of my variables, I'm being asked for how many hours were spent by car and how many hours are spent by ferry. So I'm looking for the time spent by car and time spent by ferry. I'm going to let those be my variables. So I'm going to choose x to be the time I travel by car and y to be the time I traveled by ferry. Okay, and for the rest, I'm going to try and fill in all the information I know. So for example, we know that they travel 880 kilometers in total from St. John's to Halifax. We don't know how much of that's spent in car, how much is spent in ferry, but we do know that there was 880 kilometers in total. So that might be useful information that we can use. We're given the speeds by each mode of travel. So by car, they travel at 80 kilometers an hour, and by ferry, they travel at 16 kilometers an hour. Okay, and we're also told here that the total time for the trip was 27 hours. So my total time here is going to be 27. Okay, so I'm going to try and use all this information here to come up with some different equations. So for starters now, if I actually look at my column here for time, I'll see that I know the total time, and I have already defined variables for the time for car and ferry. So I actually have an equation already. Looking at this column, I know that the time spent by car plus the time spent by ferry will be 27 hours in total. Okay, so I can use that to get my first equation. Okay, so again, time spent by car plus time spent by ferry will be 27 hours in total. And that's a really good start to have that one equation down. I'm going to see now for a second equation, because right now I can't solve it, I need a second equation. Can I generate another equation? Well, I know there's 880 kilometers total. If only I could find out some information about the distance traveled by car and ferry, because I could create something simple, something similar, not necessarily simple, but similar. If I know the distance traveled by car and distance traveled by ferry, I could create an equation there as well. So what I'm actually going to do here, and you may remember from science last year, there's a relationship between distance, speed, and time that exists. So essentially, speed, because it's in kilometers per hour, is distance divided by time. Okay, the other way you could see this, if you multiply both sides of the equation by time, is you could say that distance equals speed times time. Okay, so essentially mean that if you travel at 20 kilometers an hour for 3 hours, so 20 times 3 would give you 60, you'd be traveling 60 kilometers. So let's see if we can use that information here to create an equation for distance by car and distance by ferry. So I don't know the distance by car, but I know that they travel for X hours at 80 kilometers an hour. Well, if distance is equal to speed times time here would be 80 times X, or 80X. Okay, for the ferry, something similar. I travel for 16 kilometers an hour for Y number of hours, so speed times time would be 16Y. And once I have that, I actually have enough information here to create a second equation. Distance by car plus distance by ferry is 880 kilometers. So 80x plus 16y is equal to 880. Okay, so again, a lot of information going on in this question. Once everything's organized and you play around with the distance, speed, time formula, you can create some equations. So let's take a look at this in Desmos. Okay, so there they are in Desmos. You can see the intersection 0.720, which means I spent 7 hours by car, 20 hours by ferry. Okay, so that's it, that's all. Again, we're going to spend the next couple of days looking at methods of solving systems of equations without graphing. So there's some practice there in the homework that you need to work through. Now again, with all of these, we're only working on defining the variables and setting up the equations. Do not solve them. You're going to be solving them in homework later on. So by getting it done now, you'll save a lot of time later on in the unit. And if you're still not comfortable with some of this, you want to see more additional types of problems that are out there, there is a worksheet on the website that has lots of different situations that you can try and set up with solutions as well, so you can see if you're on the right track. So the worksheet is optional, so only if you're feeling not comfortable with all this. But do make sure you do the stuff in the homework, because we're going to be working with those questions later on. Okay, so that's it. That's all.